Hello, welcome back to the next lecture. So today we're going to continue with the probability stuff, and we're going to try to recognize the most common distributions. I'm Professor Wu, so let's get started. So we previously learned that probability distributions, by knowing them, they're like really, really useful. Once we have the probability distribution, we can calculate probability of events. We can do conditional probability, identify dependencies between data, perform Bayesian inference, basically make better life choices or business decisions. However, in life, people don't just readily hand you a probability distribution. You don't have it. Instead, what you have to do is collect data and essentially use the data to create your own model of a probability distribution, which is called parameter estimation. Large portion of data science and machine learning is basically the process of learning this like probability distribution, P of X. There are many ways to find a probability distribution. Here's a short list of a whole bunch of them, right? And we're going to go over the most basic methods, which are shown in red. Okay, we've also learned in the previous class that the easiest way to visualize data is histogram. So we learned histogram in the last class. However, histograms are not probability distributions. They are more of a visualization tool. We can visualize the distribution, but it's not the same as a mathematical function. Today, we're going to learn one of the easiest way to convert data into a distribution. Statisticians have long recognized and realized that there exists a list of distributions that occur very often in nature. And they have identified these equations to model these natural phenomena. So, if you recognize the appropriate situation for these distributions, you can essentially directly get P of X because it has already been recognized that for certain situations, it's suitable for certain distributions. So they're essentially, we're going to learn, I mean, there are a lot of distributions, but we're going to learn six of the easiest, most commonly seen distributions. The first one is called Bernoulli, categorical, uniform, Poisson, exponential, Gaussian distribution. Okay. All right, so let's start with the very first one, Bernoulli distribution. Bernoulli distributions describe events with exactly two possible outcomes, and we put that as 1 or 0. So that it could either be 1 or it could be 0. For example, which basketball team will win the game? Team A could be 1, team B could be 0. Okay? Or is it going to rain? Yes for 1, no for 0. Or is the student going to pass or fail? Pass equals to 1, fail equals to 0. For example, let's say you have gone to 40 good interviews and 60 bad interviews. Right? In this case, the probability of having a good interview is 40 out of 100. So it's 40%, 0.4. And probability of bad interview is 0.6. Right? So if given this as the data, 100 interviews, 40 bad, good and 60 bad. What is the P of X then? Well, it's actually pretty easy. First, recognize that this is a Bernoulli distribution. And since this is a Bernoulli distribution, then the equation looks something like this, where theta is the probability of 1. Okay, so we know that probability of 1, which is a good interview, is 0.4, probability of 0 is 0.6. So this right here, you simply plug in the probability as of success into theta, and that is your equation. Okay, so right here, let's take a look. So theta is 0.4, 1 minus theta is 0.6. Okay, and that's this right here is the equation. And at a first glance, you might not see why this is the equation, but remember, this is a Bernoulli distribution that you can only plug in 1 or 0. So let's try plugging in 1 or 0 first. Notice if you plug 1 or 0, if you plug 1, right, notice that 1 goes here and 0 goes here. because it's 1 minus 1 equals to 0. Therefore, this cancels out, which says that the probability is 0.4, which is the case, right? Probability x equals to 1 is 0.4. And conversely, if you plug 0 in, notice that if you plug 0 in, this will be 0. And 1 minus 0 is going to be 1, implying it would be 0.6. So here is the probability of success. Here's the probability of failure. Basically, like split into two categories. You kind of turn one on and turn the other one off. Okay. So this right here is the equation. Let's go from data to Bernoulli distribution. Given a data of ones and zeros. So let's say this is the data. Okay. You count the number of ones and then divide that by the total number. Basically, you want to know the probability of success, which we're going to set as theta. Once you have theta, you just plug it into this equation. And that is your P of X. All right, so for your first exercise, we asked 4,000 couples at the end of 1 month of dating whether they're still together or they've broken up. This file can be loaded here, right? Identify P of X given this data. Okay, so this is your first exercise. Pause the video. Here's the answer. You can look at it when you have the chance. Okay, the next distribution is called the categorical distribution. Categorical distribution describe events with more than two possible outcomes. So previously we had two exact outcomes as Bernoulli distribution, but now we have more than two, like 3 and more. Okay, so which number will die row, right? What's the weather going to be like? So there are multiple possible options. Which candidate will win the election? So, for example, let's say you ask 100 people their favorite meal of the day. 40 people says breakfast, 10 people says lunch, and 50 people says dinner. What is the probability distribution P of X? In this case, we have three possible outcomes. We have three possible outcomes, breakfast, lunch, and dinner. Therefore, the input is a vector of three variables, x1, x2, x3. And the way that works is that if it's breakfast, then it's going to be 1 0 0. So 1 0 0. Notice it's 1 0 0. The second option is if it's lunch, then you're going to plug in 0 1 0. So the first one is ticked or the second one is ticked, and the probability of dinner is the third one is ticked. These are the possible inputs you can put in because there are three situations. So you're basically saying that it's either the first X1 happen, X2 happen, or X3 happen. Okay. So this is what we want, where if we plug the first one in, we want the first was 0.4, right? Probability of lunch was 0.1, probability of dinner 0.5. In this case, P of X for categorical distribution looks like this. Theta 1, theta 2, theta 3. So theta 1 is the probability of breakfast, theta 2, and theta 3. Okay, those are the three of them. And x1 to the power of x1, x2, x3. So it's the idea looks very, very similar to Bernoulli distribution. Okay, where it will be 0.4, 0.3, 0.5. Notice how now if the first one was picked, then the first probability is set up and other ones is canceled out. And if the second one happened, then the second probability is kind of plucked out while the rest of them are canceled out. So you don't need these anymore. Okay. So Bernoulli and categorical distributions are both really similar to each other. Like what you need to know is basically 1 or 0, and you're either turning them on or turning them off. Okay. All right. So here's another example. Graduating salary of Northeastern students. So this is a categorical distribution. I want you to pause the video and practice the idea of how you can get P of X out of this. Okay, pause the video. The solution is here. So when you have the chance, take a look. All right. When to use uniform distribution? That's the next one. Uniform distribution is a discrete distribution. Discrete. So uniform distribution happen just like categorical. Uniform is a categorical distribution. The only difference is you know ahead of time that every probability is the same. They're exactly the same. So for example, when you roll a fair die, like 1 to 6, right? Every possibility is equally likely. Oh, which car suit would you get? Would you get spades, diamond, heart, clubs, right? It's equally likely 1 out of 4. So a uniform distribution is simply a categorical distribution where all the probabilities are the same. However, because the probability is the same, P of X is simply 1 over D, which D is the number of categories. So if there are 6 categories for rolling a die, then the probability is 1 out of 6. Or which car suit would you get? It will be 1 out of 4. Okay. So in this particular case, as long as you know what the options are, 1 over D is your probability distribution. Now, there's a continuous version as well for the uniform distribution. Right? It could be both discrete or uniform. So, for example, where would the MBTA train break down? Right? It could break down anywhere uniformly between point A and B. Therefore, when it breaks down, like it's a continuous thing. So from point A to point B, they're equally likely to break down. Or what angle would the falling pin point towards? Right? So it's 1 over 360 degrees. So a uniform distribution, when it's continuous, then the probability distribution is simply 1 over B minus A, right? So if the range is A over B, then the height must be 1 over B minus A, which is this distance here. And this makes sense because this distance is B minus A, right? And if you want the area, the total area, then B minus A times the height, they should equal to 1, which is the total probability. So that is the equation for uniform distribution. Next one is the Poisson distribution. A Poisson distribution is a discrete distribution that describe outcomes that normally happens on certain average likelihood, but gets less and less rare as X increases. So let's say, what is the probability of n number of chip will be effective? Well, you notice this is discrete, n number of chips. And more likely than not, you're going to have a couple, like maybe 3 or 4. But the probability you having more than that, 16, 17, 18, it gets very, very unlikely. Okay. Or distributions that describe the number of people waiting in line at the bank. So when you show up to the bank, how many people are going to be in front of you, right? So probably you're going to have a couple, but it's unlikely, right, that you have 100. Or number of deaths a year. Okay, so a Poisson distribution, the equation looks like this: theta to the x, e to the theta. So just like a bunch of other distributions we learned, if you know the theta value, if you just know the theta value, you can plug the theta in and you have the whole equation. So the question now is, what is the theta value? Well, the theta value, it turns out that if you were to find the expectation of this distribution, P of X, find the expectation, the theta is the expectation. So this means that if you just know the average, you can plug the average value in here and you have the equation. So it's pretty easy, right? So expected number occurrence. So let's say on average, so this is expected, you meet 4 new people in a month. what is the probability you will meet 20 new people? Okay, so you want to pause the video. Remember, if you meet 4 people on average, that means theta has equal to 4, right? Then you can calculate the probability of meeting 20. Okay, pause the video. Okay, the solution is here, right? You plug 4 into theta, and then you plug 20 into x. All right. The next one is called an exponential distribution. An exponential distribution is a continuous distribution that describes an event that becomes less and less rare as x increases. So, amount of time a postal worker spent on a customer. Right. So chances are the postal worker will spend, you know, half a minute to a minute, but it's unlikely that they spend more than 2. You see, more than 2. So a distribution that kind of drops down like this is called exponential distribution. Okay. So, for example, if on average people first drop their phone in half a year, what is the probability that they never drop the phone within the 2-year plan? Okay. So that's an example of a problem you can solve. And the equation for exponential looks like this. Theta e to the minus theta x. And at this point, you know the pattern. You just need to, once you recognize it's an exponential distribution, you just need to figure out what theta is. And it turns out that if you find the expectation of this distribution, it's 1 over theta. So with Poisson, it was theta, but with exponential, it's 1 over theta, implying that if you know the average occurrence, right, and you take 1 over the average occurrence, that will give you theta. So for exponential distribution, that's how you do it. And once you have the distribution, then you want to find certain probabilities. You need to take the integral to find the probability. Right, here's the next question. At work, at Google, an average load time for search is roughly half a second. And your boss comes and say, hey, guy, machine learning guy, under normal operation, what is the probability that a user will experience longer than 2 seconds? So, longer than 2 seconds will be, unacceptable. Identify the appropriate P of X for this problem. Okay, so you should be able to identify this, and then use Python to perform integration to find the probability of experiencing this. So you can use Python, and you know how to find the integral now, right? mp.inf is the NumPy version of infinity. Now, if Google has 1 billion users at any given time, how many users will experience lag time of higher than 2 seconds? Okay, so pause the video, do this as your next problem. I have provided the answer here. All right, so the next distribution is called the Gaussian distribution. They're also called normal distribution. We've done this in a previous video before. A Gaussian distribution is used a lot for basically everything, like IQ score, height, weight, they're all here. So here's an example. Given the retirement age of NBA basketball player, what is the appropriate probability distribution? So that's age is yet normally a Gaussian distribution. And the equation looks like this. Now with Gaussian distribution, you know the equation, and therefore all you really need to know is the mean and the standard deviation, and we can just plug it in. So finding the mean is easy, and you guys already know how to find the standard deviation. So this is how you get the equation for Gaussian-like distributions. So it tells you that the mean is the mean and the variance. Standard deviation is the square root of the variance. All right, let's practice this concept. If a Northeastern student graduated high school, if on average, Northeastern student graduated high school with a GPA of 4.1 and the standard deviation is 0.3, Then what is the P of X that describes this data using a Gaussian distribution? Now you can next take your own high school GPA and calculate what percentage of NUU population had a lower GPA than you. Okay, pause the video. This is the next exercise. All right, if you solve that one, here's the next exercise. You're trying to model how much time you spend texting. You found that you receive on average 10 texts an hour. What is the probability that you will miss 8 texts in the next hour when you have your phone turned off? Okay, so you want to do that one. The answer is here. All right, so once you have identified the probability distribution P of X mathematically, right, you can then use SciPy to do various things. So you can essentially do the PDF, so the equation, as long as you know the mean and the standard deviation. You can do the CDF, and you can do the PPF, which we've done all these before. All right. Now, this last time we've only done the Gaussian distribution. This time we have other, like you want to keep track that like other distributions. So instead of normal, we can do exponential or Poisson, right? Or uniform distribution, right? So Poisson, you just need to know the mean, right? And then you can find the PDF or CDF, PPF, right? So basically all the distribution we learned so far are part of this, and you can find the probability CDF, PDF using these tools. Okay, and and whenever you have a data, right? What we've done so far with the data is basically use histogram to plot it out, so we can visualize it. Now, once we have the histogram, that's not the same as having the equation, right? So that's why we learn what we learned today, so we know how to get the equation. Now, if your equation is an accurate representation of the data, then if you plot out the equation, which will be the actual line, it should be really, really similar to the data itself. Therefore, a very good test to see whether you've done a good job fitting to your data, finding the distribution, is to draw the histogram and then plot out the lines, right? And here you can see that the data is very, very close to the actual predicted equation. Okay. Yeah, so this one is exponential. Yeah, this is more of the same thing I talked about previously. Okay, as your last practice, you want to go to a website. We've worked with these 3 files before, right? And what I want you to do this time, after you have the histogram, is to approximate P of X. So figure out the mathematical equation given the data. And once you have the P of X, I want you to plot the probability distribution right over the histogram. So ideally, you will look very similar, right? Ideally, your equation you've predicted is very close to the actual histogram. Okay, and then after you've identified Gaussian, calculate a couple things, such as what is the probability that x, right, is less than 1,000, right, and then count the number of scores less than 1,000. So this question is saying that you can essentially figure out what's the probability of someone scoring less than 1,000 on SAT. But you can also use the CDF function. So one way is to just count it. The second way is to use the CDF. And obviously they're not going to be the same because what you've done is the approximation. But they should be relatively close. Okay. And then use PPF to find a score of score that's higher than 80%. And then the last question is about the wait time, right? You want to use Python CDF to find the probability that someone has to wait longer than 3 seconds. Okay. All right. So these are the questions. I want to pause the video, go over them. I don't think Yeah, I didn't really provide the answer for this one, but they should be visually obvious. Okay, that's it.